So today we'll be starting chapter 9, and there are a couple topics that we're going to talk about during the chapter. The first one is something called a wrapper class. So remember in Java 1 we talked about Java having 8 primitive data types, which were byte, short, int, and long. Those were for whole numbers. We had double and float for decimal numbers. We had char, and we had Boolean. So those were our 8 primitive data types. They're called primitive because they are just built into Java. They are not created from a class. And what that meant was they didn't have any methods on them. So I couldn't go to a byte and say, you know, dot something. And so because they are not classes, what Java did was it created some wrapper classes for these primitive data types so that we can actually call some methods on them. These wrapper classes are part of java.lang package. So we don't have to import them, just like the string class you don't have to import, or the math class we don't have to import. So anything in java.lang is automatically imported for us. Now, the wrapper classes, each one of the primitive data types has a wrapper class associated with it. The one for ints is called integer. So if I want to represent an integer, the integer 12, for example, as a class, I can create an object that is of type integer. So integer is a class, we call it a wrapper class, and basically all it does is store that number that we want. So here I'm saying create me a new integer that stores the number 12. Now why do we need to do that? There are a lot of reasons. And what we're going to do is I'm going to show you some of the ways that we can use a wrapper class. But here, just like we can, if I want to change the value, I can just say doesn't equal to a new integer, that's 15. If I want to get the int value out of it, these wrapper classes have methods. So this integer class has an int value, and what that int value gives you back is that number that's stored. So if I was to go to doesn't and say give me the int value, since now it's storing the number 15, I would get 15 out of it. And the other nice thing that these wrapper classes have, another method is called a parse method, the parse methods. These parse methods, what they do is they take a string and they convert it to that number. Okay, so if I type in, if I have a string that's 10 and I want to get the int value out of it, I can go to the integer class and call a static method on it. And the static method is called parse int, and I can get that 10 out of it. So let's look at some examples before we continue. So let's say I want to create an integer, and before I do that, I want to just show you something in NetBeans. If you go to Tools, Options, and then here click on Fonts and Colors, you could actually change the font color. So font size. So if 18 is small, you can make it a little bit bigger so that it's a little easier for you to see. So I'm just going to do that so that you guys can see better in the video. So let's just review. We have byte, I equal 8, for example. If I wanted to create a class out of that, I would use the byte class. So it's the same as the lowercase, as the primitive data type name, except they start with uppercase letters. So we said classes always start with uppercase letters. So byte, let's call it my byte, and we say new byte, and I can give it the number 8. Now, if I want to just print it out, I can do that. And what doesn't it like? No suitable constructor for byte. Okay. Let's say I, which is a byte. So what can I do with this byte? Well, one thing you can do is just print it out just like you normally do. Say print me byte, and I will get the 8 printed out to system data once it wakes up. There we go. Now, the other thing we said is that they have parse methods. So let's say I have a string value that the user entered, and let's say it was the number 9. Okay, so they entered it as a string, and now I want to know what is this number. So what I can do is I can go to the byte class and say byte, and there you'll find a Parse Byte method. So the Parse Byte takes the string. So the integer class would have a parse int. The byte class has a parse byte. The short class has a parse short. So here, if I say parse me that value and I want to store it, so let's say I is equal to, so this byte, I'm going to change the value to be whatever it was that's parsed, and let's print out I. Let's see if it can actually convert that string 9 into a number. And it was able to convert it to a number. If I wanted to print one more, well, here, if I want to print one more, I should put the plus plus first so that it does the increment first before printing. So I should get a 10 printed out. Okay, so the first thing is that you can create those classes with those with a value in there, and just like let's go through all of them. So if I want short, let's say s equal to new short, and I can give it like a number in there. I can say, what doesn't it like here either? So it just thinks that it's a number. It's a int. Let's just say short equal to 1,000. Let's call this one my short. So we saw byte, we saw short, integer, for example, equal new integer, and there's one for long also, my long equal to new long. And then we said there is float and double. So I can say float, let's say my float equal to new float 8.9, and we can do double also. Double equal to new double 7 point. So you can create all these classes. Now each one of them has a different parse method. So we saw that the byte has a parse byte method. Now, if I try going to the short, for example, if I go to my short, it's not going to be parse byte, it's going to be parse short because it's a short. So it's going to have a static method. So I should go to the short class. Dot parse short. So if I want to, I have this short and I want to convert it, this string, and I want to convert it to a short, I can do that. And let's just copy this line. And then we can do the same with all the others. So if I want like a double, for example, it would be parse double. If I wanted it to be like, if it's a float, then I'd go to the float class. And there I'm going to find a parse float. So all of them have the same name. All the ones that are numeric have the same name as the primitive data type that we're used to, except that they start with an uppercase letter: byte, short, long, float, double. The only one that's different is integer. Instead of int, it's the word integer, it's spelled out. And then the parse methods are all parse followed by the type. So parse byte, parse short, parse double, parse float, parse long. The only one that's different is parse int. Instead of parse integer, it goes back to the name of the primitive data type, which is parse int. So those are some of the methods that you can use. Now those are for the numeric data types. How about characters? Well, character, the primitive data type is called char. The class associated with it is called character. So I can use the character class to create an object. So for example here, I can say character my char equal to new character, and I can give it a character in there, like the letter L, for example, or any character. Okay, and what doesn't it like here? Oh, it needs to be a character. So here I can create a character object from a single character that I have. Now, why would I need to do that? Well, because the character class has some methods that might be useful. So there are static methods that are built into the character class, just like the static methods that are built into the math class that give us functionality. Here, the character class has some static methods that also give us some functionality to help us test what is this character. So if you have a character, you can test if it's a digit or not. So for example, if you is entering their phone number. Okay, so let's have a string phone equal new, well, equal to just 888-111-7878, for example. And I want to see if this string is a phone number. Well, what I can do is I can go through every single character. So I can say for every char, or let's use a regular for loop for int I equals 0, I less than phone dot length, I plus plus. So I want to go through every single character in my string, starting with index 0. And here we can't use I because we used I before. So I'll just change this to J. I is so common in for loops that I want to reserve it for our for loops. I don't want to introduce a new character in our for loops. But here I'm going to go through every single character, starting with the first character, which is at location 0. I'm going to go up to the length of the string. I don't want to include its length because if it's 5 characters, I want to go only from 0 up to 4 in indices. And what I want to do is I want to grab a character. So I'm going to go to the string, and I'm going to say, get me the character. So I'm going to use char at, and I'm going to tell it, get me the character at location I. So I'm going to get the 8, for example. And what I want to do is I want to check if it's a character. So I can say if, and I go to the character class and call the static method is digit. Okay. And I'm going to ask it if current is a digit. And here, what I want to do, if it's not a digit, then there's a problem. So if it's not a digit, I can say system.out.println character at location plus I is invalid, for example. Now, this is not going to work exactly like I want it because this string has some digits in it, has some dashes in it. So it's telling me that whatever is at location 3, 0, 1, 2, 3, that dash and the second dash are invalid. So I probably want to do an exception for it. So I probably want to check these 2 locations. So first, if it's not a digit, I need to check if it is a dash in a valid location. So if current equal to a dash, if it's a dash, and I is equal to 3, here I want to put this in a loop, in parentheses, and I is 3 or I is 7, then it's okay, right? So what I want to do is I want to kind of say the opposite of this. So if it's a dash and it's at 3 or 7, it's valid. So what I'm going to do is I'm going to put an exclamation mark and just put parentheses around that. So if this is not valid, then give an error message. And in that case, we should get that we don't have anything printed out. So it's valid. Okay. So this is one of the use cases for the character static methods that you can go, if you have a string, you can actually go and visit every character and test something about this character. So you can check if it's a digit, if it's a letter, you can say if it's a letter or a digit, is it lowercase, is it uppercase, is it the space character? So these are all methods that you can use. Now you can also convert the characters using the to lowercase and to uppercase. So remember before we learned that we can if I have a string, say name, and let's put my name in there, and I want to convert it to uppercase, what we can do is go and just go to the name and say to name, I want you to change it to all uppercase. So what this did was it gave us back a string that was the uppercase equivalence of name. And so if I run this, I will get my name in all uppercase. Well, we can do that with the characters also. So here, what I could do instead was I could say for every character C in name, what I want to do is I want to go to the character class, and I'm going to use the to uppercase method, and I'm going to convert this character to uppercase. Okay. And I think C has been used for each, not applicable to expression type, required array. Looks like we can't do for each on strings. I thought I could do it. I'll check that later. But for now, let's use the regular for loop again. Name dot length. I plus plus. And so here we want to go to name and get the character at location I. So let's try that. And so here it's printing them all on different lines. So let's use the print instead of the print ln, and they'll get them all on one line. So here, this is just another method that the character class has, to uppercase, which does the same as the to uppercase that was on a string, but it does it on a single character. Okay. So here's an example, and we're going to talk about J-option pane in a little bit, but for now, here we ask the user for a character, and we're checking, is this character a letter? Is it a digit? Is it lowercase? Is it uppercase? Is it space? Is it white space? So we can call different methods on the character class. These are all static methods that we can call. Another use case of the wrapper classes is that now we can use them to store these kind of primitive data types or these numbers in array lists. So let's import an array list. Import java.util.ArrayList. And remember, when we talked about array lists previously, we said that when I'm creating an array list, it has to be an array list of objects, like strings, for example, or bank accounts or students. So we had to be creating objects to store them in array lists. We couldn't do something like array list of int numbers. We couldn't do that. So this was not valid. It will complain that int is not a class. So it says I want a reference. Basically, reference means a class. I want an object that I can store a reference to or the address of. So what we can do instead is use the integer wrapper class. So here we can do array list of any of the wrapper classes, and they will work because primitive data types are not working chars. New array list. Okay, so this is another use case for these wrapper classes, that you can just store them in array lists. And so now I can go to numbers and I can just say add. And the nice thing here, I can just put a number and it will work. Even though here this number 9 is just an int, it works. What happens underneath the hood in Java is that it converts this 9. It actually creates an integer object and saves it. So this is the same as saying add a new integer that has the value 9 in it. These both are equivalent. And so if I try to print out my numbers, I'm going to get that it has 2 9s in it. Okay. So I see that it has 2 9s in it. So we're going to talk more about this in another lecture, but I just wanted to show it to you right now.